Good morning and good afternoon, and welcome to this video on computers and peripherals, identifying and defining the parts of a PC. PC stands for personal computer, and their associated functions. Now, real quick disclaimer. You need to understand that everything that I talk about in this video directly relates to the larger personal or desktop computer. You're going to see images of that here shortly. But the concepts from this also pertain to other computers as well. This includes laptops, Chromebooks, smartphones, tablets, and other smarter devices. So let's get things cracking because I have a 15-minute time limit on my videos. Here we go. So big ideas for the 6th grade. After this lesson, you should be able to identify some of the various components of a PC and explain what the components are used for. Additionally, the purpose or the big idea is to build interest in information technology and improve on your knowledge of PC or computer hardware. We also have some essential questions. In other words, you should be able to answer these with relative ease for 6th grade by the time all is said and done. How do the parts of a computer work together for the user? And what are the parts of a computer and why are they important? Now, we're not going to cover each individual circuit. We're talking about broad things. And you're going to figure that out real fast as we start rolling here. All right, so the basic personal computer. As I said, we are talking about desktop computers. Desktop computers are the things that either sit on the floor or sit on the desk, okay? And they have a separate monitor and keyboard. They may also be what they call the all-in-one, and I'm going to show you an image of that here shortly. This right here is the computer itself. This is not the computer. It's really interesting. I used to tell students, hey, turn on your computers. And they would just turn this on and off and on and off and say, Mr. Candle, it's not working. Well, they never turned on the desktop computer when I was in my business lab at LCMS. So understand that this is the computer itself, and this is just displaying what is going on in the computer for us as users to interact with. All right, now you might have an all-in-one computer. An all-in-one computer contains this item right here and the monitor all in one unit. So you can think of this as kind of like a glorified tablet, a little bit more powerful tablet. In fact, some of these are nothing more than tablets themselves on stands, effectively speaking. Now, that's not always, but for most cases. Now, some people also argue that desktop computers are going the way of the dodo. I disagree with that. You see, there's a big difference between desktop computing, which is a little bit more powerful computing, and network computing, which requires more networking power, but less computer processing power. Okay, so your Chromebook is an example of a system that uses primarily the network to help do its computing. Okay, so it's not very powerful because it relies on software and infrastructure on the internet. Desktop computers rely on their own software and infrastructure. Okay, they're a little bit more powerful. Now, the all-in-one unit is, again, the same as a desktop, but it has everything contained. Okay, now the desktop PC is the system unit, which is this right here. Okay, it's the computer itself. We call it the system unit. You might also have a monitor, which is an output device. All right, we're going to explain more about output devices here in a few minutes. But effectively, when you connect it and it's working, it is displaying information out to you. And of course, the computer and the mouse, which are used as input devices because they're putting information into the computer. Alrighty, and you can see again, you have the system unit behind the screen itself. The monitor here, or the screen, or the display is the output device. Of course, you got your computer and mouse as input devices. Even if they are wired or wireless, they're still inputting information and commands into the computer. Alrighty, now some terms you should be familiar with. Here we go. Let's go into a little bit more details here. First, we have a storage device. Storage devices do nothing more than keep, house, and store data. Okay, some people use the word data. Potato, okay? But they keep, house, and store data. They maintain that data. Now, that data might be stored portably, say like on a flash drive, or on, like my GoPro uses a micro SD card, as you see here, or some of the older computers may use a hard drive such as this right here. We'll talk more about that a little bit later on, okay? But those keep, house, and store the basic information for the computer. Now, output devices are information or hardware that puts information out. Now, that information can be anything, whether it's printed data, okay? In other words, data that has been transferred to paper that we recognize with our eyes, all right, for human interface. And then, of course, another human interface is data or sound signals that are sent to computers in which are translated to audible sounds for us humans. Notice that output devices are pretty much useless without human interface of some form, unless it's computer-to-computer talk for networking and coding and what have you, and that's a story for another day, okay? But for our purposes here, okay, output devices send information out of the computer, all right, so from the system unit out to us as users. Now, input devices put information into a computer. This might include something like a flatbed scanner. It might include, I didn't get a webcam here, I put a personal camera here, although people don't use these anymore because they got smartphones. However, if you have like a webcam, such as the one that's on the top of your computer screen or your display on your Chromebook, okay, or even the little devices that kind of hang out on the top of monitors, okay, those are inputting information into the computer. Now, something really unique about these cameras right here is that these contain input devices, in other words, the camera, the lens, and the software inside. They contain storage devices to keep, house, and store the data. And then some of the nicer cameras, of course, have displays out that you can see the image of what you just took a picture of. Now, let's talk a quick moment about coding and code, okay, in its most simplest form, okay? So we're going to talk about storage here. But understand that computer code comprises primarily, in its most simplest, easiest to understand form, zeros and ones. Zeros and ones. They're equivocal to ons and offs. Ons and offs. All right? Now, if you arrange the zeros and ones into a certain sequence, they might represent something. Example, you might have a bunch of zeros to represent, say, a space. Or you might have a sequence of 0 and 1s to represent a certain sound. Or a sequence of 0s and 1s to represent a certain color. Okay? So a bit is the smallest unit of data, 0s and 1s. And you string enough 0s and 1s together, and you get something that in middle school we'll call a character, okay? So it's a letter, a symbol, a color, a pixel, something equivocal therein, all right? So you string them together, and you got characters, all right? For us tech nerds out there, current computer systems use 256 lines, 128 lines of code, or characters of code for operating systems and such. If you don't know what I'm talking about, that's okay. We're at 6th grade. It's okay. All right. Older computer systems used as low as 8 bits. In fact, the original Nintendo Entertainment System was known because it was an 8-bit system. In other words, they used 8 sets of 1s and 0s to create colors, codes, text, images, sounds, so on and so forth. Okay. Then they went to 16, and then they went to 32, then they went to 64, and then they went to 128. You get the idea. They have to round up to get more information stored in there. All right. Now, when you fill up one of those spaces, whether they're 8 characters long, 16 characters long, or 32 characters long, you have a byte of data. In other words, one memory storage location. One storage location. Now, if you combine and take kilobytes, okay, that's 1,000 bytes. Alrighty? So 1,000 bytes of data. You have 1,000,000 bytes for a megabyte. By the way, most older text files, okay, before Google Docs and before Microsoft Word and such, they were only like 12 and 15 kilobytes in length. And that was primarily because, not because of the text that was on there, but because of the pages and the formatting and so on and so forth. All right. Raw text files may only be, say, like maybe a kilobyte total in length, if that, depending on how long the information is. So you can imagine that books and books of data wouldn't even fill a megabyte in length. You also have a gigabyte, which is a billion bytes. In other words, a billion of these storage locations stringed together. And of course, you have a terabyte, which is a trillion. Just to give you an idea how much a trillion bytes is, okay, I built a computer that for my video editing and sound editing, it is a very strong, powerful PC. I put 4 redundant cards in there so I wouldn't lose data, making up 2 trillion bytes. And of all the videos that I have on my YouTube channel, I understand that I have over about 200 hours on my YouTube channel. I keep everything stored on the computer, all right, on a single terabyte drive. Okay, so that's a lot of space. That's a lot of information and a lot of memory. All right, so again, they're all stored on a storage device. So again, just to clarify, you got bit, which is the simplest line of code, a 1 or 0. You fill up a sequence of 1s and 0s in different combinations, and you might get a letter, a character, a symbol representing a byte, which is 1 memory storage location. Okay? Then you put 1,000 memory storage locations together, you get a kilo, mega, giga, tera, so on and so forth. All right, so that was really easy. That brings me to our questions. So if you're in Mr. Cato's class, you should see attached to this video link on Google Classroom some questions. Remember, you're going to answer these questions, but because they're in slides, okay, you can't just input the information. You got to use the text tool, draw your text box in, and answer the questions. Or you can circle it as long as I can see the circle. All right, make them bold if you're going to use the shape tool. If you don't know how to use the shape tool, just simply type in true or false, and make sure you answer that last question there. And don't forget, there is a slide 2, so there are some questions in there as well. All righty, folks, that brings me to the end, and we'll catch you on the next video.